Okay, we're going to do problem 23 in chapter 3. This is on page 78. And the problem says that the position of a particle as a function of time is given by r equals 5.0 I hat plus 4.0 j hat times t squared, and it has units of meters. Okay? And it asks two questions. First of all, it says, what is the particle's distance from the origin at t? So find, here, let me do it this way. Find r of 0 seconds, r of 2 seconds, and then r of 5 seconds. Okay? So what we're going to do is, the first thing we have to do is plug in these different times, and then we're going to find the magnitude of the vector, basically. So for the first part, we're going to have r of 0 seconds, so we're going to put 5 I hat plus 4 j hat times 0 squared meters. Well, that just ends up being 0, because when you put 0 and multiply it out, it ends up being 0. So the distance from the origin at 0 seconds is 0 meters. Okay? So that's the first one. The second one is at 2 seconds. So we're going to have r 2 seconds is equal to 5 I hat plus 4 j hat times 2 seconds squared. And the units will still be meters. So 5 I hat plus 4 j hat, 2 seconds squared is equal to 4 units of meters. And then we're just basically going to distribute that 4. So we're going to have that our vector is 20 I hat plus 4 j hat, plus 16 j hat. Again, units of meters. And now we have this, so we can figure out what the magnitude of this is. So the magnitude of r at 2 seconds is going to be equal to, well, 20 squared plus 16 squared square rooted. Let me plug that into my calculator here. And so 20 squared is 400 plus 16 squared is 256. We're going to add those up and square root it. So the magnitude of r at 2 seconds ends up being 25.6 meters. Okay? So we're going to repeat that process with r at 5 seconds. So first of all, we have to figure out what the vector is at 5 seconds. So we've got 5 I hat plus 4 j hat times 5 seconds, quantity squared in meters. 5 I hat plus 4 j hat times 25 squared in meters. Oops, sorry, not 25 squared, just 25. 5 squared is 25, so we're good. Now we're going to distribute the 25, so we're going to have 125 I hat plus 100 j hat in meters. So that's the component form of the vector. So now we want the magnitude of this. So that's going to be given by 125 squared plus 100 squared square root. Okay, 125 squared is 15,625 plus 100 squared is 10,000 square root. So we add those up and then take the square root. So we're going to have 25,625, and the square root of that is 160. We'll just go with 160.1, I guess, meters. Okay? So part B says, find an expression for the particle's velocity as a function of time. So what we want to do is we want to find the vector v as a function of time. So the vector v is going to be the time derivative of the position vector. okay? So we're going to take d dt of 5I hat plus 4j hat times t squared in meters. This is going to give us, well, we can kind of pull out this part because basically this is constants. We don't have to worry about that part. So we just have to take the derivative of the t squared. Okay, the derivative of t squared is going to be 2 times t, and then we can multiply through the 2 since that's also a constant. So the vector v, vector velocity, is going to be 10I hat plus 8j hat times t in meters.